Okay, today what I'm going to do is show you how to set up a part to print that you created in SolidWorks. Once you've made your part in SolidWorks, you're going to go to File, and you're going to save it as an STL file. Just a different file format that's used for a program called Cura. So here's the part that I saved. It's called Poly. Choose the file type, go down to STL. Click Save. I already had one called poly.stl before, just when I was testing things out. You're then going to open a program called Cura. All right, there's the name right there. That pop-up window, I already have it open, but you can go to your Start menu and do a search for Cura is the name of the program. All right, when the program first opens up, you're going to get Configuration Wizard. We have two. Sorry for the alerts there that are going off. We have two printers. We have a Series 1 Pro and a regular Series 1. You can go ahead and set it up as a Series 1 Pro. The difference is that it's a heated bed. I haven't really examined what happens if you tell it to heat the bed and doesn't have a heated bed. It's probably fine. I do like the quality of the Series 1 Pro a little bit better. You can turn the analytics off. All right, this is one feature that's added to the Cura program. It's showing a 3D fill. We'll come back to this later, but supposedly makes it a lot stronger. This warning is just saying that you need to put some kind of material down when you're printing. Some plastics will permanently bond with the glass. All right, we always use the blue painter's tape as a protective material. Also makes it easier to get off, in my opinion. All right, when you go ahead and open it up, you might have a object on the bed. I think other students have had a cone on there. You can just right click on the cone and tell it to delete the object, or you can right click on the platform here. This is kind of like our virtual printer here. You can right click on the bed and tell it to delete all objects. What I'm going to do now is go File, Load Model File, and find that STL file that I created, that poly, and it will insert the poly onto the platform. Now, one of the first things you need to figure out is how you want that poly to print. And by that, I mean you can't print on top of air, okay? For instance, when it's trying to print this arch at the top of the hole, there's nothing underneath it, right? That's a little more obvious if you click on this view mode and go to overhang. All the overhang is going to be in red. These are places on the part that don't have anything underneath it, okay? So one thing you can do is tell it to put in support material. So it will actually add material underneath there to give it to something to print on. All right, now the reason I bring all that up is because you could also rotate the object by clicking on one of these icons down here. Click on the shape, and I just realized that my screen is cutting that off. Okay. Hold on a moment. Sizes, sorry, that's probably very difficult to watch. All right, so down here at the bottom, there we go. we've got the icons to rotate it. So I can click on one of those, and one thing I could do is lay that fully flat. I could click on this. It's the wrong one. I just rotated around about the Z-axis. That's not going to be it either. It's going to be this green handle now. I could rotate that. I don't know why it's doing 89 degrees. It's a little odd. Do it again. There. Now it's allowing me to do exactly 90. That's interesting. I just changed my view, and now I could rotate 90 degrees. Okay, now the problem though, if I try printing that, you're going to see the overhang. All right, all this underneath here is going to have overhang. So in other words, it's going to have support material printed all on the inside of the pulley. That's a lot of cleanup that I have to perform after it's done printing. All right, in my opinion, this shape would come out better if I have it rotated the original direction. I can rotate it back. You can also right click on the shape and say you want to reset all object transformations, and then bam, it'll go back to how it originally was. Okay, some of the settings over here that you can change, let's just talk about those. Most of them are about the quality of the shape, the detail, how precise it is, as well as how solid it is on the inside. This layer height right here, that affects the quality. 0.2 is kind of a rough draft. 0.15 is kind of middle of the road, and 0.1 is for higher detail. But the more detailed you make it, the longer it's going to take to print. And you'll probably notice that as you hover over, it tells you what that setting is for. So this says shell thickness. It's used to determine the thickness of the outside shell. So basically the walls, the walls of the shape on the sides, it's 0.8. I read somewhere that they recommend doing that a multiple of the nozzle size. The nozzle size is 0.4, so you could do like 0.4, 0.8, 1.2. Of course, if you did 1, it would be fine. It would still print, but that's essentially doing 2.5 layers according to the nozzle size. This is the thickness of the top and bottom layer. So this is like the walls on the outside. This is the top and bottom. Usually, if you want equal strength on the top and bottom and sides, probably make those the same, pretty close. The infill type, you can have different types of infill. The 2D does like a grid. The 3D's what I showed you, what you saw in the beginning of the video. Concentric or circles, and so on. I usually do 2D or 3D. 3D will probably give you the highest strength level, but it may take a little bit longer to print. The infill distance is going to affect the percentage that it's filled in. 100% fill is going to give you the strongest shape. It'll be a solid object. If I decrease that distance, basically the fill will be closer together. All right. And you'll see if I decrease that distance down here, the infill percentage changes. If I change that to 1, we're looking at 40%. If I changed it to 0.5, we're looking at 80%. 0.2, which it doesn't like, it says it has to be at least 0.4. It cannot be less than 0.4. Why? Because that's the size of the nozzle. In other words, it can't make the filament smaller than what's coming out of the nozzle. And that doesn't make any sense down here. Infill percentage 200. So I can do 0.4. That's the smallest you can go. All right, that's 100% fill. All right, so If you want 100% fill, you can make it 0.4. Change it back to 0.8. Now the fills are twice the distance apart. It's going to do 50%. Okay, printing speed. Usually I think that's set as 60. The slower you go, the more precise the part's going to be, but the longer it's going to take to print. I think usually somewhere around 40 to 60 is fine, but again, I think I usually have it at 60 for now. We can I can post settings. We think we should tweak that a little bit. The printing temperatures set by the software according to the type of material. Sometimes you can change that yourself. Sometimes you might get better quality at 240. There's a lot of little factors that affect like how much string residue is left. If your part has a lot of little fine threads, sometimes you can increase the temperature a little bit. Sometimes you can slow down the print speed. Sometimes you can make the layer height smaller or larger. And all right, bed temperature, that's set by the printer itself and the material. The support type, that's basically for the overhang. Okay, you can basically says I want overhang everywhere. The touch build plate only does it when there's space between the part and the plate itself. So like right here, here's the pulley, there's space between the plate and the pulley, so basically it wouldn't do support material here. It's not updating because it's having to recalculate. My computer's running really slow right now. Not sure why. Probably because I'm recording and trying to use a pretty advanced software, and I got Solidworks open as well. All right, the raft, the brim, that basically is for an initial adhesion layer. Okay, if you do brim, the brim basically is like kind of the brim of the hat. It just goes around the perimeter. All right, so if this calculates, I really like to show it to you. I'm going to try to close SolidWorks and see if it'll open up. Right, I don't want to take up too much video while I'm trying to close stuff. All right, well, anyways, the brim basically just goes around the outside, just helps it stick a little bit better. The raft actually does a full layer on the bottom, basically prints out a layer and then sets the part on top of it. Increases the print time. This is just not cooperating. All right, okay, and that's about it. Okay, oh, now it finally goes to SolidWorks. And so if you have any questions, you can ask me. The next video that I need to make is how to go from the Cura program. Oh, left out one important detail. When you're all ready, okay, when you want to actually print, you're going to click on File and then Save GCode. Very, very important. Otherwise, you have nothing for the printer to use. So you'll save that GCode, and then you're going to go into the printer dialog and upload it. And I will make another video on that. All right, so anyways, hopefully this wasn't too confusing or frustrating to watch, and you can always ask questions, of course.